We are currently in the teaching area in the Biomechanics Lab, and in this lab we are having a capacity of offering 25 students to have a class here. And we usually take a tour, introduce what is biomechanics to our undergraduate students. We also have graduate students coming to get some hands-on experience for their classes. So one class I'm teaching currently is advanced topic to learn how to process data, work with biomechanic approaches. We are having students coming and we capture the movement and we learn how to process the data, digitize them through specific software, and also get hands-on experience on having research designs. So in general, we are having students lining here. We are having monitor facilities, whiteboard to support our teaching area. And in the future, we hope to get more hands-on experience for our undergraduate students as well. So having labs in the Biomechanics Lab is one of the goals for next semester. This is a 2D video camera. As you can tell, these are very small, easy to bring. It's the best part for those cameras is you can bring it to the field to capture motion. And then after that, bring the video back to the system so that you can use their software to digitize it. It's relatively cheap to purchase and also easy way to work with real-world scenarios. For example, we can bring those cameras to a conference and capture the videos. After that, we can bring those videos back to do the technique analysis or performance analysis. We can capture their, for example, approach running speed and what is their takeoff angles. All those information can be done through this tiny camera here. We are also having a pair of force plates here. Those are portable force plates. I use them mainly for teaching purpose. So we have students standing on the plates. We can easily measure their counter movement jump. So students are learning how the force curves goes while they are jumping. And by having those data, students can process their own counter movement jump data. We use the force curve to calculate the jump height. We also calculate what is the impulse to understand impulse momentum theory. Now we are looking at a curve which is very typical in biomechanical world. So this is a curve for counter movement jump task. So what we did for the task itself is subject standing still and then they're kneeling down and then jump up for maximum height. While doing this movement, they have their hands on hip, and that is in general what happens here. And when the subject starts to jumping as those black dots, that is an event when the subject starts. So during this time, as you can tell, the force curve changed a little bit. And then once the subject's kneeling down, the force curve is going down a little bit, and then until close to the lowest point, subjects pushing the ground, and then that is when the curve is going up. Well, at this moment, as you can tell, the force tends to zero again. So when that happens is the subject's taking off. While we are leaving off the ground, the force turns to be zero. That's the time we are flying in the air, and that also the time can tell us what is the jump height for that subject. Once the gravity brings our subjects back to the ground, here is a force rather sudden and turns to very big, as you can tell here. This is a landing event, landing part. So based on this curve, we can use the impulse momentum theory, also maybe flight time, to calculate the jump height. And this is actually a data from one of our students in the class. So we collect data from our students and we process the data for themselves. This definitely makes our students more interested about what we're doing, and they have been very much enjoyed process their own data to look at who jumps higher or which trials they did better. So currently we're in the testing area, which we also call it as a research area in the lab. So in this area, we are having 8 three-dimensional cameras, and we're also having a system to digitize those. What those systems give us is the trajectory of each marker, because now when we're doing research activities, we will place markers on subjects' bony landmark. By knowing that, it can help us to calculate where is the joint center. We also can understand what are forces applied to each joint and what torques occurred. So for example, how much effort you are using while you are jumping and how much forces you are experiencing while you are landing. So those are what those cameras with 2 force plates can give us. It will give us three-dimensional data, which could be forward, backwards, left, right, and vertical up and vertical down, those forces and motion capture systems. So currently, we are having all those research projects. We're collecting data here. We're having the system on, and several undergraduate research assistants. They are helping with studies. So they help with participants' recruitment. They're also helping place markers and talking with subjects to get hands-on experience learning how to use professional equipment here. What we're looking at now is called white balance testing. We also have a set of FM testing kit in the lab. So for the anterior cruciate ligament injury specifically, so this is a screening task. We have subjects standing on this white balance system with their toe aligning here, and they're trying their best to kneeling down and pushing the blocks forward. We're measuring their distance, and that is a study we are currently looking at to see what has been changed after ACL injury and what are those data between the ACL injured participants and the healthy controls. ACL here means anterior cruciate ligament injuries. This is a vertex jump height measurement. We use it as an easy way to measure participants' jump height. For class activities, we have students do a maximum jump and measure their jump height through this measurement. It can automatically, not really automatically, but it can immediately telling you what is a number. Then we use force plates to measure the same movement and calculate it through our theory. So we compare the data from between both ways. By doing that, students understand what we're doing and get a better sense of those numbers for class. And then for research activities, we're also using this in order to set up a research environment. So for another study I was working on is called trunk perturbation, how that gonna affect the knee loading while we're doing jump landing activities. So we will have set up or measure participants' jump height by using vertex first, and then set up a goal for our participants. By doing that, participants will focus on their maximum jump height while doing it, and then to conduct research activities. So this is a hip abduction machine, and what we're using it is to measure the maximum contraction strength before the data collection. So we will have the sensors placed on participants' muscle belly, and participants try their best to against the motion, so that by doing it, we know what is their maximum strength. And then they started to conduct jump landing activities and some research tasks. We normalize their muscle activation based on their maximum strength measured at the beginning, so that we know if they're activating how many % compared to their maximum strength. This way makes the data comparable between individuals. We also understand better by looking at if they're activating more or less while doing different tasks. So in here, we also have a treadmill and some spine bags. By having those, that really helps our athletes to participants to warm up before the testing. And we also look at how the running movement, running analysis between treadmill and overground running. Thus, we are using the same gait pattern between those two surfaces. those activities are very good for class, for teaching purpose. Students really feel like, oh, I run a lot on treadmill during winter. I also run a lot outside. Which one is better? Should I keep an eye on any specific part? That are some information we can tell from teaching.